Hey everyone, how's it going? Welcome to the stream. All right, so a couple nights ago, after I wrapped up support for recursively defined types and forward declared types, then I spent the rest of the stream fixing a scope bug that I discovered, which is now fixed. As I wrote here, it's something that happens because when a function has no variables in its root scope, like in this example here, it has like a couple of subscopes. The stabs generated doesn't include scope info for the root scope. That caused me some problems because I always assumed that there would be a scope defined for the entire function, regardless of whether there were variables or not. Like if you do this, everything's fine. But once you remove that, what was happening was I was seeing this scope as the first scope of the function, the first opening scope, and assuming that's the one that starts the function. And then this one here, since it matches with this one, I'd be like, oh, okay, so the function is now defined. And then when I'd get to this, I'd be like, hey, I don't have a function I'm defining right now, and I'd assert. What I do now is I always force a scope, a root scope, every time I start defining a function. And then I had to add some code to detect when I'm done defining a function because it was no longer as simple as the closing brace. And so when I reach a certain point, which is actually when there is no more stabs line coming after, at that point, I look to see if I still need that extra root scope. Most of the time I don't, but in these situations, I would have this one extra scope. In this situation, I would keep it as is. But let's say I would have like a variable at the root, then I'd have a root scope that I create, another scope for this here, and then these ones underneath. So I basically check for that condition. Say like, oh, if the root scope has only one child, replace it with its child. And that basically fixed the bug. So I think I closed my Git extensions here. So anyway, I wrapped that up after last stream. Did a little bit of cleanup as well. Let's see here. Yeah, this is the one. So fix assert when function has multiple scopes, but no variables declared in the outermost scope. So it's all explained in there. So yeah, now this example here, if I hit F5, here we are. We're about to enter main. You can see everything looks like it's working. Before it would just actually fail because there would be an assertion. Here you can see A because we're in this scope, and then here you can see only B because we're in that scope, and A is closed. And once we're back out, there's no more local variables because there are none in this outer scope, and everything's good. So that's cool. So that brings me back to continuing to work on adding support for stuff. So yeah, what's next? So many things to work on. So this is done. Add support for pointers, add support for self-referential types. And I said this may be related to supporting forward declarations, so that is the case. So after that I wrote stuff. I have here add support for bit fields. Definitely want to get to that. There's also some stuff about this and vtable, but one thing I realized is that what I really need to do, let me see here. Did I write it down? Right, yeah, okay. And I'm sorry, I'm looking for if I wrote down support for arrays. Yes, okay. So many things to do. All of these things have to be done. Okay. So I guess I didn't write it down. So actually this is done. So okay, I'm gonna add it here. I wrote add support for unions. I'll say add support for arrays. I think I'm gonna work on arrays. I could do unions. Unions are somewhat similar to structs, but I'd like to do arrays because I feel like I should have done arrays before even doing structs. They're very important basic like primitive data type. So I have primitives. So and when I'm talking about arrays, of course I'm talking about the C-style array. So let's just take a look at what that would look like. I haven't done at all. I don't even think I've looked at what that generates. So let's just start with a nice simple something like this. Just see what that generates. An int array. Okay, so what do we have here? So we have a variable declaration, but what distinguishes this from normal variable declarations is this extra equals, then AR, presumably array, AR26 equals to R26, 0 minus 1. That is quite a bit more info than I expected. Let me try something. Let's just do that. I want to compare the array to the irregular. Yeah, look at that. So much data for arrays, huh? So I guess 0.9 here might be how to index it. Lots to part. Okay, so it's not as simple as I thought. Let's go see if I can get some info about arrays in our stabs info here. So we've got maybe in variables. Oh yes, parameters. Got to do that as well. Okay, so nothing there. Let me see what else we can get here. Okay, oh, here we go. Aggregate types, array types. So ngsim and lsim. So I think that's the difference between global and local. So we will see these in both cases. Right now we'll focus on the local symbol, which is 128. So type descriptor is AR, symbol descriptor capital T. So here you go. As an example of an array type, consider the global variable below. Since the array is a global variable, it is described by the ngsim stab type, the symbol descriptor G, followed by the colon in stab's string field. Let me see. Following the colon, okay. So char vec colon G19. So that's not the case for non-globals. Let me see what it looks like for a global. Make sure we have something that's matching what they describe. All right, so yeah, okay, so G, so there is this extra G here before the number, so that's interesting. So the lack of a number is what makes it a local, or the lack of a character, I should say, before the number. Otherwise, there's a G there, okay. Following the G is a definition for type as shown by the equal sign after the number. I think what's happening is it's getting, let me remove these locals. Yeah, okay. Good, good. So after the equal sign is a type descriptor, AR, which says that the type being defined as an array. Following the type descriptor for an array is the type of the index. A null field, the upper bound of the array indexing, and the type of the array elements. I see. Fascinating. So let's see if we can put that together. So we've got this, the name of the variable here. It is a global variable. Its type identifier, I think, that's what they call this. The type definition number is 19 here, equal to an array. And then it said is the type of the index 1. I think in our case, the type of the index is 26, and that corresponds to, what does it correspond to? I have no idea. Is the type of the index. I would have thought that in this case, the type of the index would be int. And then I would have expected to see like a type 7 in there. But here, it's, for me anyway, it's a new type, 26. I don't have any 26 here. 24. I'm not even sure where 25 is supposed to be. Oh, right. So the global is type 25. So it's actually defining a new type. And here it doesn't actually show the extra equals, so it's a bit confusing. So it doesn't quite match. Let's see. Equals to type descript array, index type ref. So here they say it's int. That's why they get a 1. Whereas for me, it looks like it's defining a brand new type. It's a lot like these ones here, where it's like self-referencing types. So like T9 is equal to, and it references type 9 here. So we have these like self-referential types. So I think we're just going to have to treat it as such. So like this is a type 26, which is defined in terms of itself. What's weird is, what is the difference between the type of the index versus the type of the element itself? What does that tell us? I almost feel like I don't really care about the type of the index. Should I care about it? I don't even, I'm not even sure what's the point of knowing what the index type is. We'll see. Then after that it says a null field, so I think they mean nil here, so like it doesn't really matter, so it's a value here. They just put 0. Is that what it looks like for us? Yeah, this is, so it's a field we don't care about. Then the upper bound of the array indexing, so here they put 2, but for us we have -1. And the type of the array element, so there's our 7. Hey, what's up, Brahim? So there's something a little funky here. My guess is what's happening here is we're seeing 2 parts here. I think this bit here equals R26 semicolon 0 semicolon -1. This here is the extra type info that's missing. Friday already here in Singapore. All right. That's true, right? And I'm saying that this here is the extra bit because, so let's say I split this here. When we look at like these types that have the equals R, what they do is they define a range for the type, right? So here I think what they're trying to say, which I don't really understand why this is like this, but it's saying, all right, we have an array. It's the type of the indexer is type 26, so it's a new type, and then they define that type in terms of itself, saying that its indexing or its value range is from 0 to -1, which I suppose means it goes from 0 to maximum in unsigned to a maximal value. So again, not quite sure what the point of that is. Like if I had I have different types, does it make any difference? Let's take a look. So yeah, so you can see that the first one defines the indexer type here. The next one just tells us that the indexer type is the same one as the one that was defined here. Again, I'm not sure why the indexer type is important. What's really important for us is what comes afterwards. So let's say I was to just ignore pretty much all this, right? So there's our next semicolon, there's the nil that we were talking about, followed by the size. So that's like, or the upper bound. So we go from 0 to 9 here. That makes sense. You see we have 99 here and we have 11 here. So that makes sense. And then the next thing is the type of the array, the type of the elements, right? So 7 here would be integer, right? That's we have up here. Whereas 13 should be char, yeah, and 22 should be bool, which should be actually an enum type, and there it is. So that's good. Curious if we were to put like a pointer in here. So let's try star p. And it equals to star 7, so that's good. Let me see. We've got, so nil, 9 is the maximal value. Actually, I think this is doing that thing again where it defines, once again, I'm going to have to do like a match here. It's defining a new type, 30. So that's a bit annoying. So they say 30 equals to star 7. Wonder why they need the 30 there. Is it because, oh, probably because I haven't defined the type for pointer to int yet. That's my guess. Like if I was to define a pointer int up here, you know, like int pointer. So that, if this comes first, my guess is this will be defined as some type, and then it'll look like that, you know, but for variable, global variable declaration, let's say. And then this here won't look the same. Let's see here. Int pointer g25 equals, so 25 equals star 7, so type 25, and then over here we see type 25. So it's type 25 basically defines pointer to int. But this is just like with the structs. It means that we might see the, it's once again the pointer match garbage, where when we see it, it may be defining the type and declaring a variable of the type, which is exactly what's happening up here. And if I remove this, it's what's happening for our array here. So this is saying we're defining a new type, 30, and it is a pointer to type 7. So this is just like the structs. When I had a struct and I put a int pointer in there, all right, because it's not a global, so it's going to be up here. We have this 26 equals to *7. So it's exactly the same thing. I got to parse, just like I parse it out of structs, I'm going to have to parse it out of integer declarations. Fair enough. Okay, so I'm getting a clearer picture than what we have to do. So let me see. Let me try to copy a couple of these. And actually, I didn't really want to do them as global, so let me just put them in local. We'll start with local variables. It'll be the same thing, pretty much. Yeah. Yeah, exactly. In fact, I'm going to call it I, just so that I remember the PI. You know what? I think I'll even run out of stack with large arrays like this. So let me make these smaller. So this will be 1, 2, 3, and 4. Let's say. Okay. All right. So let's go try and write a matcher for our array type. Okay, so I'll put it like around here. Hey, what's up, Bam? 1964. Teach me how to code, please. Well, hopefully, if you're watching this, you'll pick up a couple things. So, all right. Yeah, I realize actually probably I'm going to have to, once I get the globals and statics and all that, I'm going to have to modify these so that they can be used in those different contexts, because I realize there's a lot of overlap there. I'm probably going to have to beef up these matches and add to them the type of the variable we're matching. So maybe it won't be so much an LSIM match as much as just a symbol match, you know? The L here implies local. I think, assuming that the format is relatively like stable between, and all it is like, as we saw, adding a G for global. I think it's an S for static. If that's the only difference and everything else is the same, it should be easy enough to extend my matchers and to modify the code to like support what type of variable we're creating. And in fact, here, array variable declarations. Yeah, I suppose in a way arrays don't define a new type, so they sort of don't quite fit up here. They're a lot closer to the way structs work. So maybe I'll actually move it a little bit closer to structs here. And it actually might be helpful if I just show something like I should probably have done this for the other types. It's really helpful to see where they come from. Yeah, like this. All right. Call that an LSIM array match, match base. So the usual. Now we got to come up with our regex for this guy. So this here, let me grab these. So these are my test strings. Got our GM in there. Okay. So we're going to match some variable name followed by a colon. And I have a nice capture for numbers that looks like this. That grabs the number followed by equals to AR. So that's how we know that it is a array. And now after that, I have a whole bunch of garbage that I don't care about. Either it's just a number or it's a number, it's like a type thing. So I'm gonna have to like capture all the way up to here if it's followed by an equals. So let's first match the number. And then we will optionally match. Oh wait, what happened here? Oh, okay. That was just me. And then we'll say that we might get an equals. See if I do this. So we'll say like equal up to semicolon, but 0 or more. Well, it's actually 0 or 1. So I guess I can do or like that. Now, unfortunately, again, I have to match, to capture this. Is there a way, regex? What is the question I want to ask? Basically, it's like, why am I forced to use a capture group when I don't want to, See how this is my problem. See how it says you need to use parentheses for grouping, but then the problem with parentheses is that they are also used for extracting groups, which is a bit of a waste. And I suppose I have no choice. Let me try alternation without parentheses. Although the presence of brackets necessary for the OR also captures the digits. So you see it says here, although the presence of brackets, I guess they mean parentheses, necessary for the OR also captures the digits to be, so it says necessary for the OR. To be strictly equivalent, you would code this to make it a non-capturing group. Ah, yes, non-capturing. So if I put a question mark colon, I can turn it into a non-capture group. So that's what I'm looking for. Question mark colon. That did not work. Ah, jeez. A non-capturing group. Yeah, it does that. It does do that. Question mark colon. So now it includes this in the full match here. Oh, wait, maybe it's okay. Maybe it is doing the right thing. Let me pay careful attention here. What do we have? Group 1, I, group 2, 25. Okay, this is good. If I do this, I end up with this group. But if I do this, I don't have this group, and I've continued matching. Although it eagerly went to the semicolon, so I think I got to put a question mark before it. I want it to go to the first semicolon. Oh, then I guess I could do that. Put one here. Alright, it's because it's like a lot of semicolons. So maybe I should be explicit about everything that I want to ignore in there. So it's equals to I guess R so let's go like this, equal to R some digit, semicolon, some digit, semicolon, some digit, semicolon. Did that work? Doesn't look like it. Oh, it's because I got to put negative here. That's so annoying. What did I do for the negatives? Oh, I did this. Oh, I actually did the non-capturing group here. Funny. because I forgot. This is really gross, isn't it? Can you do like, no, never mind. I suppose another way I could do it is I could say equals R dot star semicolon dot star semicolon, because I don't really care about at all the format of these, I think. So let's just do that like this. Okay, good. And now I can go to the front of this thing here and do the question mark colon to ignore the capture. Oh, that didn't actually work. Like that. There we go. All right. Then we hit a semicolon, and then we want to capture the lower bound. Then we want to capture, no, sorry, that's just the 0. I wonder if I should just put 0, but maybe it's not always going to be 0. So let's do that. And here, like that, and like, no? What just happened? Oh, right. Yeah, I think this is good. The last part is the type. Okay, so we have the variable name. Then after that, we have the type. What's it called here? 25. Actually, what is the? So what is that 25 again? Symbol description. Global type definition. Why, does it actually define a type? I suppose it does. Oh, that's interesting. I suppose that means that if I have a second type that is exactly the same, I will need to define a type for the array. Makes sense, I guess. Let me see. If I make it like another II here, of the same size, let's say. Yeah, there you have it, 25. Okay, so it is actually like a pointer. It defines a type and a variable. So I here is of type 25, where 25 is equal to this array type. So this will match just a variable, a normal variable thing. I think if I put a 2 here, that will actually define a brand new type. So that means we need a type for every size of array. Yeah, you can see it here. Interesting. It's kind of sad actually, because it means that, well, I mean, I guess it's all right. Yeah, so it is a type definition. Type def ID or type def number. That will be the next part. Then we have this whole part that we basically ignored. It just tells us it's an array. Actually, I guess, do I want this 20? No, I said I didn't care, right? We don't have references to those, do we? Doesn't look like it. So, all right, then that means that the third thing that we match, group 3, is supposed to be the nil value. I suppose we don't even need to capture it if we don't care about it, right? We could do the same thing. So we can say, actually, match it, but don't capture it. How about that? And then the third thing we need here is the type. Let's see. Group 1, group 2, group 3. Oh wait, I did the wrong one. It's this one we don't want to capture. So 1, 2, so 3 ends up being this guy here. Orange. 0, 1, 2, 3. Oh yeah, upper bound or upper index. Index upper bound. If I could spell. And then finally we get a type string. What did I call it here? The LSIM I called it. Will that make sense? The LSIM string, A:7, P:. Actually, for me, unfortunately, it doesn't look exactly the same. So I can't LSIM match this one. So in my case, it's just this part of the LSIM. Now, what would I do there with the LSIM? I just need to be able to add a type if it's a pointer. That's the thing. If it's not, then I just need to do nothing with it. Let me see. Let me go back to my RST parser for the LSIM struct. So here we did an LSIM match. And if it was a regular LSIM, it's a variable declaration. Otherwise, it was a pointer match. In my case, what do I want to do? If it is a pointer, I need to add the type just like I did here. Otherwise, because what I could do is I could put the I colon, let's say. I don't really care about the name. It's a type definition. Variable type ref ID, and in the variable name, find the type by the variable type ref ID. Sure. But for me, yes, okay, I do need to find the type if it's just a normal type. So same thing as I do with structs. And when it's a pointer, you see here, member type. And when it's a pointer, we create a type, and that's what we move into here. So that's what we would do for the pointer as well. Okay, so it's not amazing, but I'm gonna have to like code around this. So yeah. Guess I'll call it LSIM type. Hey, where was I? Oh yeah. So I'll call this the LSIM type. So I'm going to say here, not the entire LSIM. For example, so I'm going to say example 7 or 30 equals *7. But not oops. Okay. Hey, mistakes being made. Did I say it's not amazing? Oh, you mean my code? Yeah, I mean, actually, to be fair, I wasn't really talking so much about my implementation as much as I was talking about like the sort of like the representation for type information. Like the more I work on this, the more I see like almost everything is exceptional, you know? Oh, sorry if I did. But yeah, it's just kind of sad how like, you know, if you were going to define a textual format for defining debug information, you would hope, especially since we're talking just primitives here, right? You'd hope there'd be some kind of consistency. It's surprisingly inconsistent, in my opinion. And maybe maybe there's another way to look at this, but so I think it's a bit of a mess. But you know, maybe what I was just thinking was like, this portion here is the type portion, and maybe instead of matching the whole string like I do like this, like as a variable match, I should be matching part of it, you know, and just saying, well, you know, just match the type info portion of it. But yeah, I don't know. Like one way I can go about this, but I'll probably break everything, but it's like to modify my LSIM match to optionally match the first part with the colon. But that's not what I'm going to do. I think I'm going to tackle it the opposite way. I'm going to like prepend a dummy name, variable name colon, with this last portion, and then use the matcher. It's not awesome, but I don't care. It'll get the job done. And I think it'll be okay. So after the variable name, I'm going to need my type def ID, as I call it here. So that's number 2. Yeah, sorry. And then this is going to be the index upper bound. And I'll call this the LSIM type. All right. So supposedly this here should match our array types. Okay. Now, go into our RST parser. I'm also going to have to add support actually to match arrays within structs, which is going to be nice. But we'll get to that. So handle stab string match. So we've got structs here, and then I'm doing type definition of variables. So I think I'll do the pointer enum. I think, does it really matter? I guess it doesn't really matter where I put it. We'll put it, okay, I'll put it below enumeration. What do I call it? A LSIM array match. Okay. Why is my this happens sometimes, my like extension for save see? Okay, now it's gonna work. Or not. So you're supposed to format on save. Alright, Control RD. I don't know. You see? Once in a while, Visual Studio just kind of craps out on me here. It's enabled. Let's do disable, enable. Oh, okay, it's working now. It's like the NES cartridge. You got to blow in it a little bit to fix it. You just got to mess around and save a few times, and it'll wake up. So all right, so let's say we've got our array match. So now what do? I grab the variable name. I'm gonna have to create a type for this. So let's go do that. Okay, so an array type, I guess similar to structs and indirect types, will have a type that it basically is an array of. It will have the size, right, or the number of elements. So we'll call it. I want to call it size, but I don't mean size in bytes, right? I mean element size. So maybe I'll just put like number of elements, num_lms, and then we need, what do we need? Maybe that's all I need actually. Stupid question, but what is this that you're making? IDEs are amazing, but I haven't ran across any software that makes me more frustrated at the same time as of yet. I think these are two separate things, right? You're asking me what am I making, and then you're also remarking that IDEs are both amazing and frustrating. Yeah, I mean, I think... No, I got what you're saying. I think the reason why we probably find IDEs to be frustrating is because it's the tool we use the most, you know. But like maybe if we were, you know, writers, we would be complaining more about Word, or you know, for accountants, we might complain more about Excel or something, which goes to show how much I know about what accountants use. But anyway. They probably don't use Excel that much. But anyway, yeah, Visual Studio, you know, it's not perfect, but I have used it for a long time. And the thing I do love about it is the debugger. So until I can get like a better debugging experience for free, basically, I'm going to be sticking to that. As to answer your question, mistakes being made, what is it that I'm making? So what I'm doing is, so basically, you know, I wrote an emulator for the Vectrex. So I'm going to assume you know what the Vectrex is, and that I wrote an emulator for it. And this is the code base for the emulator itself. And what's interesting is that most programs for the Vectrex are actually written in assembly, but you can actually write programs in C++. So somebody wrote well, for C, I should say, and C++. I had to add support for C++. But basically, it's a fork of GCC. It's an old version, 4.6. somebody basically modified, like forked it and added the backend for the 6809 CPU, which is what the Vectrex uses. And with that, and a couple of like scripts, you're able to compile a C or C++ program, and this generates like a binary blob. And there's a couple of scripts to like put in the necessary header and stuff like that. And then you've got this like binary file that you can stick on a ROM and put that on a cartridge and shove it into your Vectrex, which I've done like physically, or you can just use an emulator to load the ROM, right? So that's cool. But it turns out that there is absolutely no high level, source level debugging facilities. Well, I mean, I shouldn't say absolutely no. There is one tool out there that does its own kind of like C parsing and tries to give you a debugging experience. But I wanted to do something like that, and I wanted it to have C++ debugging. So usually when you use GCC, it generates debug info, like with the -G, it'll generate dwarf. So dwarf is like the format for debug information. It's kind of a little bit of a pun. It generates ELF format for the binary, the executable itself, and it'll generate dwarf for the debug symbols. But unfortunately, this fork and targeting this CPU, it does not generate ELF nor dwarf. It generates this like binary blob, as I said, for the 6809, of just a blob of instructions. And if you ask it if you pass it -G, it generates this listing file, and it puts in there, it's a textual format, and it puts in there these lines, these textual lines with the keyword .stab. There's stab S, stab D, stab N, but the point is they all start with stab, and this actually is it's an old debugging format. So it's this here. The stabs debugging symbols tables. That's what it actually stands for, like symbol debug tables or something, or symbol tables, whatever. So this format here. So what I'm doing is I'm parsing all this information from within my emulator, and my emulator is implementing a debug protocol, which is called debug adapter protocol. So it's this thing here. It's actually a protocol from Microsoft. So it's this thing here. And the whole idea of it is to do this. You've got like IDEs, editors, and other tools that implement a generic debugger in terms of this protocol. And then you can write, or people have written adapters that can talk to the debugging environment for, say, Node or Python or C#. And so in my case, and by the way, like IDEs and editors and stuff that currently support DAP, you've got obviously VS Code, you have Visual Studio, but there's also Emacs and Vim and a few other editors. And so they speak DAP, and what I'm doing is I'm writing the actual like adapter, but my thing is, let's say, the whole thing here. So like you can imagine that it's the emulator itself that implements the protocol. And so what that means is that when you start debugging, it launches my emulator, and it says, hey emulator, can you please run in DAP mode? And my emulator just basically starts talking to the editor through this protocol. And it gets a whole bunch of commands. Like it'll say, hey, I'm loading the source file, I'd like to debug this source. And then it'll say, set a breakpoint on this source and this line. It'll say, add a watch here. All the kind of things you would imagine a debugger will tell you. Those are the kind of messages I have to handle. And then in my case, I've implemented in my emulator basically support for all those commands. So support for setting breakpoints, stopping on breakpoints, being able to step source level instructions. So like if you step a line of code, I have to step as many instructions as is represented by that line of code. So effectively writing the debugger backend within my emulator. So like kind of like to summarize, you write a program like this in C++, you compile it, when you hit run like this or debug, it launches Vectrex C, that's my debugger, and then Vectrex C starts parsing and stuff, and then it'll eventually say, oh okay, I've got it, I've loaded all the debug info I need, and I'm going to start running the program. And then you start stepping here, and there's like requests for show me variables for the current scope, and then I'll have to show these variables and show their values and all that stuff, in which case I'm doing memory reads and stuff like that, you know? So yeah, that's hopefully my long-winded explanation of what I'm working on right now. Hopefully that was clear. Oh, hey, Steven. Hey, a long time no see. I hope you're doing well as well. I'm doing all right. I don't know if you caught my super long explanation I just gave of what I've been working on, but anyway. And was the last thing I needed here. So I've got the type, I got the name. Yeah, I think that's all I really need for an array. Yeah, adapting, I suppose, is the word, right? It's not easy, as I'm sure everyone here feels. I don't want to complain too much because, I mean, I consider myself very much one of the lucky ones. I have my job. You know, I have a home. I can work from home. So I don't want to complain too much, but it certainly has its challenges. Oh, no, don't worry about interrupting. Yeah, those are not spare monitors. Those are, that's actually what my wife uses to work. Yes, our industries are indeed lucky. Office at work. Yeah, no, this is not my office. This is my home. It's been converted into an office, I think, like most people. Yeah. Yeah, we're certainly very lucky. You know, I mean, I've always considered myself lucky that I can work from home anytime. You know, like at most places, you know, how many jobs can you have where you can really be at home all the time? There are definitely jobs that exist, but you know, our work as programmers is all about building technology, and because of that, we're also really adept at using the technologies that would help us to better work from home. You know, so I feel like. Especially in like the last, I don't know, 5-10 years, there's been such a huge push for better internet speeds and just better software. Video conferencing has gotten really good and free. You know, a lot of video conferencing is free, which is crazy. And yeah, like it's and like also collaboration tools. I haven't tried it yet, but you know, Visual Studio and VS Code have this thing you can see up here, Live Share. Apparently it's awesome for, you know, collaborating on some code or even just showing someone something. Rather than share your screen, you can actually do live share. And what's cool is that the other person can connect. And they can either connect with Visual Studio, VS Code, or even through a browser. And like they can kind of anchor themselves to you and see what you're doing. But at any point, they could even like, you know, unanchor and go look through the code as if it was local to them. You know, if they're trying to understand what you're talking about, they can even go look themselves and use the power of the IDE, right? They can do like, you know, looking up by type and like using all that stuff. So it's really, really amazing. I haven't had the chance to try it, but I certainly will at some point. So yeah, we're very fortunate. Let's just say if there was a time, you know, to have to be stuck at home, now is a good time. I feel like just 10 years ago it would have been a lot harder. You know what I mean? It's also a good time to catch up on all that Netflix you haven't watched yet. Yes, 5G. That's going to change a lot of things for sure. Yeah, that's a good way to put it. Forced experiment. Okay, so let's say I've got this LSIM array. What am I going to get out of this? All right, so we get the variable name. That's fine. So I guess what I really need to do here is I'm going to need to grab the LSIM type and then do that weird thing I was talking about, which is like yeah. Yeah, that would be something, wouldn't it? Although a lot of people are taking the opportunity to write viruses and like I shouldn't say viruses, but like you know, phishing and schemes and all that to take advantage of people who are totally stuck at home right now. It's terrible. A lot of these phishing and schemes are targeting older people. And you know, because what I mean is like a lot of older people are stuck at home and they don't have necessarily you know, their younger people around them to help them navigate stuff, and so then a lot of them have been taken advantage of with these with people just, you know, like pretending to help them with their computers or IT or whatever, and scamming them. And scams that have existed for a while, but they seem to be working much more now. So maybe in a way, COVID is infecting the internet. Oh yeah, dial-up. My first modem actually was a 28.8K baud modem. I wasn't one of those who had I wasn't like early days modems on what do you call them there, on the BBSs. I totally missed that era. Didn't even know they existed. I started my online, you know, my online presence on AOL with the CDs. Yeah, so I'm gonna have to do something like this. This is very confusing. Okay. For parsing, add a dummy variable name, or so say prefix, to be able to match. We don't really care about this variable name. New generation are just spoiled. maybe. Okay, so let's say I've got the lsim like this. The other one I called it lsim member. So what we want to do is we want to do this match. Let me just kind of steal this code here. I mean, I could even put the actual name here. The only use I would see there is what I pass in there would show up in my error messages. So maybe I'll do that. Okay, so let's say we find it. Then, all right, so we found it. What do we need to do? We are going to create a type that is for our array. So we're going to go auto. In fact, no, we're going to be doing add, right? All I need is a type and the number of elements. So here I've got the type and I got the number of elements. So let's do this like this. And it's a pointer, we're going to do that, pointer type. I don't have a function like this yet, but I obviously will write one. We're going to use the array, no, the lsim array dot type define ID, type def ID. We're going to use the because I don't have a name, just have basically the type. And then I need the number of elements. So for that, we're going to just get the upper bound, index upper bound plus 1. Sounds good? That sounds good to me. And in the case of a pointer, which is going to be very similar, you know one thing I didn't do here? It just occurred to me. That's going to add a lot of complications, I'm sure, is multi-dimensional arrays. I'll get this working, and then I'll look at what adding multi-dimensional arrays would entail. We could do this in steps. Hopefully it won't be that much harder. Famous last words. I won't be able to skip this one. Okay. Is that what I call it? Or I called it num-lns. Okay. Oh yes, I do need a name. Do I need a name? Actually, I don't need a name. Suppose this is the first type that doesn't necessarily have a nice name, but I should show one. Okay, I'll construct the name. Yeah, that's what I'll do. So I'll take basically the name of the type itself. Isn't that what I use? Oh, sorry, it's the other way around. So I'll just put type here. Just move the type. And number of elements just becomes number of elements. And then we say add type, type.id of t and return t. Okay. So this gives me the type but I also have to add the variable here. So it's just like for pointers. Let me take a look again. Yeah. I have to use the rest of the info here to do the usual add variable. Almost feels like maybe it would be worth I'm just thinking like maybe it would be worth it, since I'm reconstructing part of the declaration here. I almost feel like I could put together the portion, you know, like I:25 if I just had this, if I removed all that, let's say, then all of a sudden this line would become a regular variable match and the right thing would occur for it now that I've gotten my type information out of it. And then maybe that's a way that I could reuse my code without repeating myself. Otherwise, I guess I gotta do what I've been doing. So here, yeah, so basically the same thing as I did for pointers. I'm gonna be doing it here in both cases, right? Oh, what's wrong here? All right, this is a string. So I realize that I'm repeating myself here. I'm going to hoist this out very shortly. I just wanted to look at what it would look like. Okay, so basically what we have is something like this. We do the array type here. In fact, I don't need to add the array type in this case. I just need to find it. That's right. But it's in this case that I need to add one for the pointer. That's it. Okay. Let's see if we get some matches and what this looks like. So with the current version of the stabs, I have quite a bit here to parse. So let's see, 1, 2, 3, 4. Hopefully we'll hit it to 4 times. First time would be for variable I. Oh, I have other breakpoints here. Let me get rid of those. All right. Okay, so what do we have? All right, we matched our I, so that's good. That was the complex one. Let's take a look at LSIM array here just to see if we have matches that look good. We have 1, 2, 3, and 4. I, 25, 0, and 7. 7 is a type string. What's 0 again? It's a... Oh, that doesn't look right. Oh no, it is. It's the upper bound. So it's 0 because you can only index up to 0. So we'll add 1 to that. So that does look right. All right, so we create this string I:7. So this means we're going to match the first case here because it's not a pointer. It's not a type def. We should be able to find type number 7, which is integer. So our array type is an array of type int. So this should be... Yeah, this always says enum type. This is not true. Just because we're debugging in release. And for some reason, it doesn't expand correctly. See, I don't know why it says that. See, here we can see that basically it should be this primitive type. You can see that the vtable knows that it's a primitive type destructor. For some reason it says here that it's an enum type, which it is not. So this is all garbage. But when I do this in debug, it works. So it's just some mess up with the release debugger. There's a bug there. All right, so now we're going to add this new array type. Lots of calls there. 25, there's our type. Number of elements is 1. We make an array type. We set the values in there. So the name is int of 1, which makes sense. And we add our type here. Got our stack offset, 14 bytes apparently. Hope you guys put them in reverse, I think. That's 1, 2, 3, 4, 5, 6. Oh no, there's multiple. 1, 5, 6, 7, 8, 9, 10, 11. Yeah, okay. So it does make sense that it's a well, actually, don't know. Oh no, wait. This is 2 bytes. So it should be 8. 1, 9, 10, 11, 12, 13, 14. Yeah, 14 bytes. Okay. So basically it's 1 byte for this plus 8 bytes, or 9, 10, 11, 12, 13, 14, and then this one here, that offset 14 for 1 byte. So we add the variable there. So the next match is C. So this is just a simpler version. Okay, I'm going to assume that's good. The next one, B, another similar to C, it's just that it's type bool. Okay, and then finally, this one's the more complex. This is the one with the pointer declaration. So let's see if this actually did the thing. Oh, no, it didn't. So let's see. What's the problem? Oh, yeah, that's not right. Why did it do that? Did my variable, okay, so it looks like my matcher is doing the wrong thing in the case of, what's going on here? Variable name should have been pi. Oh, there it is. pi colon 30 equals star 7. Oh wait, I see it. Okay, I'm not passing in the right variable here. Okay, should be good now. So let's go back to that case for the pointer. So here we are. So now, there we go. So now we match it. We're going to look for the pointer type, and we find it because it's a pointer of type int, I think. All right, so we're not crashing, so that's good news. So let's see what would happen with just what I have now. I think it's not going to work because I don't support arrays yet. Yeah, whoops. Let's try that again. Okay, so I think, okay, so what just happened is it asked my debugger, hey, could you expand these types? And because I don't know the types, I think I have like some, fail, like we'll attach and we should hit an assertion that says, hey, I don't know this type because I'm not handling it yet, which is great. So we'll attach. Okay. And then when we step here, we're going to get the request and we're going to assert. Exactly. So this is good. This is what we want. We're going to go take a look at our call stack. So that's it. See, we're trying to do a create DAP variable. And here you can see I'm handling the different kinds of variables. And of course, we fell into the else unexpected type because we don't, I did not write the code to handle making a DAP variable for an array. So let's try and add like a very simple implementation. All right, so what do we want to do for this type right now? I think we'll just do like make a dap variable. Yeah, so technically speaking, this is a little bit more complicated. I'm going to need to look at how to properly define. I think the way this works is I have to add, you know, a way to expand, just like I do for structs there. I have to add like a new, well, anyways, I need to add a child, what's it called? What did I call it again? Here, a variable reference, where this is the parent variable ID. And then when we try to expand it, then I need to tell it like, then I need to, I actually don't know how to do this yet. I need to look, but there's basically a way, I suppose it's similar to structs. But when you expand it, I'm going to want to show all the elements of this array. And I remember reading in DAP that there's this like kind of like a hint where you can say, or you can like say like, are there a lot of values? And you can even do it sort of like a paged. So like if you have thousands and thousands, you don't, you know, end up hanging in the debugger waiting for it to expand thousands of values. It'll just show, say, 10 or more, or whatever you decide, and then you can sort of scroll down and it'll ask for the next 10 and it'll page it and that kind of thing. So that's part of the protocol. But just for now, just at least display something, maybe I can maybe just show the first value. I guess I could do for now just what I'm doing for pointers. There we go. Okay, so let's just see what this looks like. Okay. Interesting. You see something? All right, so I've got my array type here. So it's II, display value, and then array type here. I just wanted to look at this. Again, I don't know if I can trust what I see in my debugger here, but not quite. Okay, so this is what I wanted to see. Int of 1. Why didn't I see int of 1 as my display type? Oh, there it is. So this one shows up as int of 1. But the other ones do not. So this is what this tells me is we're not correctly storing these other ones as array types. So I have a mistake somewhere. Let me see here. I guess I'm doing it correctly for the pointer type, but I did not do it correctly here. Oh, right. Or not right? Wait. I see it. I see what it is. All right, so it's not the array type. This is the type of what the array points to. The array of type. And then what this returns is the array type. So this is the array element type. Let's call it that. Let's call it array lm type. That'll make it much more clear. Array lm type, and then here we get the array type, and that's what we add. Our variable is of the array type, and the array type is built off of the array element type, which makes way more sense. I'm starting to think that maybe for clarity it might make sense if my array type here said lm type. Maybe I'll change it later. All right, so let's see now. Build this. This makes more sense too, which is why I thought it was weird that the debugger was actually showing values. It shouldn't have been showing values. It should have just been showing addresses. See now? Ah, there we go. That's better. So you see I is of type int of 1, C is char2, bool of 3, int star of 4, and int of 1. Great. So there's still more to do, obviously. Let me write down what we're going to do here. So we need to support multi-dimensional. Do that later. We need to write so dap variable, or like can expand array and display its values. I must not forget to add the forward declared support there, so the undefined array of, can I do that actually? Maybe I can't do that now that I think about it. Oh no, I can do it for pointers. Yeah, array of undefined type. So let's say, for example, we'll say struct foo, and then we'll say like foo star a of 100 or whatever, a of 10. Like if we do this, then I need to handle the undefined type. But basically what I'm talking about is the thing I did last stream. Every time I add a new type that a new sorry. Every time I add a new type derived class like this that references another type, I must remember to go and update this resolve types function, which presently goes through and iterates over everything that might have a type that may be unresolved. So like right here I have stuff to try to resolve. What is this again? Yeah, so that's it. My array of types, and then my address to function for all the scopes and for variables therein. And I'm going to have to add, basically I just have to add a case in here. See how I looked for indirect type and struct type? I'm going to have to add here to do handle array type, basically. It would be really easy to do. All right, so now that I know what to do, I think I'm going to stop here. Normally I try to keep it within 2 hours. The last few streams I actually went well over, but I'm kind of tired, so I think I'm going to stop it here, guys. So thanks a lot for watching, and I should be back at this next week on Tuesday. So yeah, I guess I'll see you guys next time.